Hey everyone, welcome back to the Unit 2 Physics 30 videos. In today's lesson we're going to be looking at questions related to gravity on an inclined plane. So there's many situations in life when an object is not simply just moving either up or down, left or right, so horizontally or vertically. And even you yourself do not just simply move in those directions. There's a lot of examples and cases that we can talk about where you're actually moving at an angle. You know, whether or not you're walking up a hill, maybe you're walking down a hill, maybe you are rolling down the hill, whatever floats your boat. Or maybe you're on a slide at the playground, because slides are still fun at our age and life is great. So with a slide, we can't, imagine having a slide that was just vertical. That would not be a great time. You just basically fall flat on your butt, and that wouldn't be great. If our slide were just horizontal, well, you're not going to be moving anywhere. You'd basically just be walking or trying to slide on a flat board or something, and that also isn't fun. So, with a slide, you have to be moving at a bit of an angle just to make sure you have that fun, to make sure that you're actually moving somewhere. So when we're talking about types of examples and calculating certain things like acceleration and force, when it comes to things on an inclined plane, this is a much different process than if we were to try and find objects that are moving either just horizontally or just vertically. So there's a bit of a different process. So, and what I would like you to do is, I would like you to pause this video. I do want you to watch the two YouTube videos first, because it's going to make your life a lot easier when it comes down to doing the examples, which we're going to jump into right away here. So please pause the video and watch those examples. As I said, it's going to be very, very important. When I jump straight to the next example, you might feel a little bit lost as to some of the explanations, just because there's some of that key stuff that's being taught in those videos. Okay? So please pause the video and watch those YouTube links, please. Okay, awkward pause. Hopefully you had a chance to go watch those videos. If not, for shame. But let's move on to our examples. Okay, so example number 1. So at what rate will a 26 kilogram box accelerate if it slides down a frictionless slope that is inclined at 22.6 degrees above the horizontal? So before we even really start any type of question, you guys know from, in class that I love to draw diagrams. I think visuals are a really important step to help us figure out kind of what's going on with the situation. And so that is what we're going to start off with. So we are going to start off with a right triangle that is going to represent the inclined plane. That is a very perfect and straight and flat right triangle. No judgment, please. And anyways, we know that the angle that it is inclined at is at a 22.6 degrees angle from the horizontal, which means that we're referring to this angle right here. Here's our horizontal line, and it's coming up 22.6 degrees. We also know that we have this 26 kilogram box that's starting at the top or starting somewhere, and it's moving on down to the bottom of this inclined plane. So now that we have kind of at least a general picture of what's going on, we have this box that's moving on down here. Now we can really try and figure out, okay, well, what information do we know, and what information can we really work with in order to find this the answer to this question? And here we're really looking for acceleration. Okay, so in this question, we know we're looking for acceleration, and we're given that we have a mass of the box. So what you want to do is you want to think back, maybe look through your formula sheet, but think about what type of equation would work with acceleration and our mass. I mean, obviously this isn't enough. Those two things alone are not going to be enough, but what kind of formula would we maybe be able to figure out some additional information? And so really, hopefully the equation that's really coming to mind right now is your force equation, which is your force is equal to your mass times your acceleration. You have the mass, you're looking for your acceleration, And so really what we have to do is we have to find out some information about this force. And so one thing that's going to be really important to make sure you guys understand is that when we're talking about the force and the acceleration of the object, we're looking at the box accelerating in this direction, which means that we need the force in that same direction. Okay? Okay, so then we can ask, okay, well, how do I find the force that's moving in this direction? I would need to know my mass and acceleration, or I would need to know something else. So maybe your thoughts have been, or maybe have gone to, well, hey, I know something else about force. I know what the force of gravity is, and that's pulling this object straight down. So that's pulling this object straight down. This one here we'll call F of G, or force of gravity. And I'm thinking that if we have our force of gravity, we can use some of the same concepts that we've used in this unit and our previous unit, that if we created maybe some sort of right triangle, you know, working with the amount or with the types of forces, that we will eventually be able to work towards finding the same force moving in this direction. Okay? So our first step here is we're going to find that force of gravity. So your force of gravity is equal to your mass times the acceleration due to gravity. So the mass of this box is 26, and the force of gravity, and this is just assuming we're on Earth, is 9.81. If you plug that into your calculator, you should get 255.06. And if you want to include our units here, you don't have to until the very end, but for force it is newtons. One thing that we should make sure that we do, as we always should, is make sure we keep track of sig figs. So the only value that we really have to consider here is this 26. We accept the acceleration due to gravity is 9.81, so we do not have to consider this with sig figs. So we just have to look at this 26. So 26 has 2 sig figs, meaning our answer also has to have 2 sig figs, which means that our significant digit there is the 5. Okay, so now what do we do with this force of gravity? And so this here follows, if you know, assuming that you have watched the videos, this here follows along with our next step is we now need to create that right triangle. So what we can do is we have, sorry, I'm looking for my blue dot here. But anyways, so we have this normal force that's going to be acting perpendicular to the surface, and we can redraw this force, or this movement, coming down here. And so what we should notice is that, I mean, if I were also to draw this really nicely, is that we would have a right triangle. So we have this force due to gravity, the acceleration, the force that this box is actually moving, and then this normal force. I'm just going to fill my value in here, so we have 255.06. So we have one piece of information for this right triangle. That is still not enough to solve this question. So what we can do next is we actually know one of the angles of this right triangle, and that is this one right up top here. So as it was mentioned in the videos that were above here, is that this angle here is actually part of that alternate interior angles property, meaning that this angle is equal to this angle right here. So this part of the triangle, and I'll write this one maybe here in red, is 22.6 degrees. Okay. So go back, rewatch the videos, or watch them if you haven't watched them in the first place, but that'll explain the whole alternate interior angles property about how we get that these two angles here are the same. So anyway, so now moving on, we can find this force that's moving in the same direction that this box is moving. So step number 2 is we can find the force, and with this one here, I believe the video had called this the force due to gravity that was parallel. If you want to come up with some other letter, or if you want to say force number 2, that works for me. I want to be consistent with the videos that you watched. So anyways, so now we can find the force of gravity that was perpendicular to the surface. And here we have an angle, we have the hypotenuse, and we're looking for this side right here, which is your opposite, which means that we are going to use the sine ratio. opposite over your hypotenuse. So then we can fill in our information. So we have sine of 22.6 degrees is equal to your opposite, which we don't know, which you can let be x, over a hypotenuse, which we found to be 255.06. Alright, so in order to solve this, we can write sine of 22.6 over 1, and then we can cross multiply to solve. So we can go sine of 22.6 times 255.06 in your calculator, and we should get and this will be a rounded value, but you should get 98.02 as that opposite side right here. And then before we move on, I am going to once again keep track of sig figs. So the only value that we really need to consider here is this 255.06. And as we saw earlier, it had 2 significant digits. So that means our answer also has to have 2 significant digits, meaning this 8 here is significant. Okay, so now we have this force that the box is moving down that inclined plane, and now we can find that acceleration. So step number 3 here is find the acceleration. So here we have our force equation of force is equal to your mass times your acceleration, and we can plug in the information that we know. We know our force was 98.02, the mass was 26, and we need to find our acceleration, which is a. So we want to get rid of the value connected with a, so we're going to divide both sides by 26. And we're going to slap that into our calculators. And what we should find is that we get 3.77 as our answer for our acceleration. But once again, we do need to consider sig figs. So here we had 26 had 2 sig figs, and this force here had 2 sig figs as well. Using our multiplying division rule, our answer as well should have 2 sig figs. Which means that our acceleration should be 3.8, and our units are meters per second squared. So this says that our box, or this box here, is accelerating down the inclined plane at a rate of 3.8 meters per second squared. So then just the last step, just to finish off this question, we need to write a sentence for this question. So we could say, the acceleration of the box is 3.8 meters per second squared. And in this case here, I'm not going to be worried about a direction. I know that acceleration can be a vector or a scalar quantity, and in this case here, we are just going to accept that it's a scalar quantity, so we do not need to include a direction. Okay, well, I am running short on time for this video, so we are going to pick up the next example in the next video.